All right. This week in the things we're studying in this week. Very exciting. The Earth's magnetic field. Who cares? I mean, why is it important? What's it do for us? Has it ever bought me groceries? No, it's never. Has it ever come to my house with free Dr. Peppers? No, it has not. Why do I even care what the Earth's magnetic field is doing? Because it keeps us alive, children. It stops the sun from shooting death beams into our brains. The Earth's magnetic field is a protective barrier. It is weaker than a refrigerator magnet. A refrigerator magnet is between 5 and 20 Gauss. Pull a refrigerator magnet off a refrigerator. That's what 20 Gauss feels like, is the force you need to pull it off. Why is it called Gauss? Because Gauss is the guy that studied magnetic fields the most. And you let go of the magnet and it goes poof, right back on. That's about 20 Gauss. The Earth's magnetic field is 0.4 Gauss. 0.4 on the screen right here. 0.4 Gauss. I need to put that up there for y'all. 0.4 Gauss. Not strong, but strong enough to keep the sun from killing us all. The sun is evil, constantly driving radiation into our atmosphere, but the Earth's magnetic field and the ozone layer send it off in a different direction. They say swerve, and it does. It goes around. Now, when this radiation goes around the Earth and reaches the magnetic poles, it falls down towards the Arctic and the Antarctic, and it creates colorful bands of light called the aurora borealis in the north and the aurora australis in the south. Borealis meaning northern lights, australis meaning southern lights. Now, that light is not deadly. It is not dangerous at all. The radiation comes into the atmosphere absorbs the radiation and then re-emits it as light instead of radiation. Light is a type of radiation, but it's a harmless type of radiation. And it's just these beautiful bands and ribbons and curtains of amazing lights. If you've never seen it, Google aurora borealis pictures. They have been seen from Texas every once in a while, but only during solar storms. So, Earth's magnetic field protects us from the sun by deflecting the radiation around, and because it has to go around to where the magnetic poles are, it gets converted into harmless light, or it just drifts off into space. So very important. Why is this important? Well, Mars lost its magnetic field, so Mars gets its atmosphere blasted off on a daily basis. Every bit of atmosphere on Mars that gets made gets blown away. All the water vapor, all the oxygen, all the nitrogen, all the hydrogen, all the helium is just blasted off of Mars by the sun. No magnetic field to protect it. Now, why do we have a magnetic field, and why doesn't Mars? The Earth has a liquid outer core creating convective induction. Convection, motion creates induction, electricity. That electricity moves with the convection, and moving electricity makes a magnet. Electromagnets are made by moving electricity. If the electricity is not moving, there is no magnet. Now a permanent magnet, like a refrigerator magnet, totally different method of making magnetism. We're talking electromagnetism here. And so the Earth's outer core moves around the inner core, and that motion creates induction, creating magnetism. Magnetism that protects us from the sun. Why doesn't Mars have this? It's a smaller planet. Its core froze. If you ever want to watch a really bad sci-fi movie, really bad, I mean really bad sci-fi movie, I can't sit through it. I have to turn it off every time I see it come on. The core, the Earth's core was freezing, and they had to dig down in a digging machine to launch a nuclear warhead at the core to make it spin again so that the Earth's magnetic field would restore itself and we'd be protected. And if the science had been a little bit better, I might be able to watch it, but I can't watch the core. It is not good science. So, don't watch it. Yes, please, it's terrible. The Earth's magnetic field protecting us from the sun is vital. Jupiter has a massive, massive magnetic field, so it has a massive atmosphere. Venus has a really big magnetic field, really massive atmosphere. Neptune, Uranus, Saturn, same story. Big magnetic fields, their atmosphere never gets blown off. And they're all way far out there, so there's less chance for it to get blown off. But Mercury, no, nothing. I mean, not even a little bit. It's a solid rock, no magnetic field, no atmosphere. Venus definitely has magma. It has 10 times more volcanoes than we have here. 10 times as many volcanoes. That means there's lots of magma. That means there's lots of liquid. That means there's big liquid core on Venus. And the atmosphere is 10 times heavier than our atmosphere. If you stand on Venus, 10 times or 100 times? 100 times more pressure, air pressure on Venus, and it's all carbon dioxide and ammonia. So not only would the ammonia eat you away and destroy you completely, but you'd be squished into jelly before it had a chance to do that. So the atmosphere on Venus is protected by a really good magnetic field. It is a very thick atmosphere. The Earth's atmosphere protected by a good magnetic field, not strong, but good enough. 0.4 Gauss. Not really powerful, but enough to protect us and make sure life is possible here. And then Mars, core froze, no magnetic field, atmosphere gets blown off. Every time water on Mars evaporates, or sublimates if you want to be really particular about it, I'm not going to get into that, no. It turns into water vapor on Mars. There's frozen water all over Mars. It's everywhere underneath that red sand. It turns into gas, gone. The sun just blasts it off. Called the solar wind. The solar wind just ruins everything when it comes to atmospheres. But the weird thing is you could actually build a sail to catch the solar wind and push a spaceship. Mylar balloons, those silver balloons, that material was invented by NASA so that they could catch the solar wind and move objects with solar wind. The project never went anywhere because building a sail big enough to make a ship move a decent speed would require building it in outer space so that it wouldn't rip, and that's really hard to do. So anyway, some little fun tidbits about space thrown in there for you guys, but the Earth's magnetic field protects us from the solar wind, helps us keep our atmosphere, and makes life possible.